Now let's talk about the notion of dependent versus independent events. And let's first define. Look at the definition. Two events are independent if whether one happens does not affect the probability of the other event happening. Okay. Now, mathematically, that means that if A and B are independent, right, then the probability of B given A is the same as the probability of B, right? So whether A happens or not doesn't change the probability that B happens. Now let's think about an example. Right? Suppose that let A be the event that you are offered a job at Southwire, right? And B be the event that you win the Powerball. Okay. Now I'm not gonna go through the math here, but it's almost common knowledge that the probability of B is equal to 1 over 292,201,338. Okay? So now the probability of winning the Powerball, given the fact that you are offered a job at Southwire, these two events have nothing to do with each other, right? So whether you are offered a job at Southwire or not doesn't change the probability of you winning the Powerball. And so A and B are then independent events. Okay? It's not like, you get a job and then the probability of you winning the Powerball is different. It doesn't work that way, right? The probability of winning the Powerball is what it is, okay? And at least in this case, it's not affected by whether you get a job or not. Now, this tells us that if two events are dependent, right, then the probability of B given A is not the same as PB. So whether A happens or not has an effect on B happening. Now, we want to know what the implication is for our multiplication rule. Now recall that the multiplication rule says that the probability of the intersection of A and B is equal to the probability of B given A times the probability of A. Right? If A and B are independent, right, then the probability of B given A is equal to PB. That means that the probability of the intersection of A and B is going to be equal to PB given A times PA, but this is PB, right? And so if A and B are independent, the probability of the intersection of A and B is equal to the probability of B times the probability of A. This is known as the special rule of multiplication. And again, this special rule only applies if A and B are independent. Okay. So let me actually note that. Only works if A and B are independent events. So now that leads us to our ways, to the three ways to check if two events are independent. First off, you can compute the probability of B given A and then compare that with PB. Or you can find the probability of A given B and compare that with PA. Or you can find the probability of the intersection of A and B and then compare that with the product of PA and PB. The idea is if any of these is true, then A and B are independent. And in practice, you only need to check one. Right? That means that you only need to check one of the three, not all three. Okay. So as long as any of these equalities is correct, then the two events are going to be independent from one another. In the next video, we will look at an example where we apply this equalities to check for independence.